Imagine a generator that never needs fuel. No petrol, no diesel, no natural gas. No monthly utility bills. Just continuous, reliable energy silently powering homes, businesses, and even entire communities. It sounds like science fiction, but according to insiders, it's real. Today, we're diving into a technology that claims to do what generations of engineers have considered impossible: a self-powered generator, operating independently from traditional energy sources and designed for continuous output without recurring costs. At first glance, the concept raises immediate skepticism. How can a device generate usable electricity without an input like fuel or sunlight? For decades, physics and conventional engineering dictated limits that seemed absolute. But this generator reportedly works on a principle that bypasses those traditional constraints. Inside the labs where early prototypes were tested, observers describe a device that hums quietly, with no exhaust, no refueling, and no external power connections. Sensors monitoring voltage, amperage, and output stability reportedly showed consistent, uninterrupted performance over extended periods. It's not just a gadget, it's a system engineered for continuous energy independence. And that has massive implications. For households, it could eliminate electricity bills. For remote communities, it could provide stable, off-grid power. For industries, it could reduce reliance on costly fuel logistics. But here's the critical point. A device this disruptive doesn't just rely on novelty. Verification and reliability are everything. Each test, each measurement, and each observation is meticulously logged to ensure the device performs consistently under different conditions. Skeptics have questioned whether these results can be replicated, pointing out that lab-controlled environments often mask real-world variables. Temperature, humidity, and electrical interference can dramatically alter performance outside the lab. Still, supporters argue that even under controlled testing, the device demonstrates a fundamentally new approach to energy generation, one that could upend energy economics and challenge reliance on traditional power infrastructure. And the potential reach doesn't stop there. Imagine scaling this technology. Entire neighborhoods or small cities could gain energy autonomy, while conventional generators, grids, and fossil fuel dependencies gradually become optional rather than necessary. But the story isn't just about the generator itself. It's about the system of verification, deployment, and access. Early versions are reportedly being distributed selectively, first to institutional users, industrial partners, and pilot programs, before wider public availability. This approach is deliberate. It ensures that when the generator finally reaches broader markets, it does so safely, reliably, and with verified performance. Yet, even in limited deployment, the attention it's receiving is unprecedented. Analysts, energy companies, and tech enthusiasts are watching closely, asking the same questions. How exactly does it generate energy without fuel? Can it scale efficiently? And when will it be accessible for wider adoption? Each of these questions touches on a central theme. Energy independence is no longer theoretical. To understand the full impact, we need to break down how the generator operates and what sets it apart from conventional systems. Unlike traditional generators that rely on fuel combustion or grid-supplied electricity, this device reportedly harnesses self-sustaining energy principles. Early reports suggest it uses a combination of electromagnetic induction, resonance circuits, and energy recycling mechanisms to maintain continuous output. While the exact technical details remain closely guarded, insiders emphasize that the system is designed to minimize energy loss and operate efficiently over extended periods. Testing reportedly occurs in multiple phases: startup, load management, and endurance. During startup, the device reaches operational stability almost instantly, avoiding the fluctuations typical of conventional generators. Load management involves simulating real-world energy demands, lighting systems, small motors, and other appliances to observe whether output remains steady. Endurance testing, according to observers, is where the generator truly shines. It operates continuously for hours, sometimes days, without refueling, external input, or noticeable degradation in performance. Despite these impressive claims, skepticism is natural. Engineers point out that laboratory conditions can mask challenges that emerge in real-world deployment. Environmental factors, temperature swings, humidity, electromagnetic interference, can affect performance. That's why third-party verification and scaled pilot programs are critical. And yet, even in its early controlled tests, the generator has attracted extraordinary attention. Energy analysts and industrial partners are evaluating the implications. Could off-grid communities achieve full energy autonomy? Could industrial operations reduce costs and vulnerabilities tied to fuel supply chains? Could urban infrastructure transition to decentralized, resilient energy sources? The answers could reshape the energy landscape. A reliable, self-powered generator has the potential to shift dependency away from centralized grids and redefine how society approaches electricity. But access remains deliberately limited. Early deployments are being offered selectively to institutions, pilot projects, and strategic partners. This staged rollout ensures not just verification, but also controlled observation of how the system interacts with existing infrastructure. At the same time, curiosity continues to mount. Every rumor, every report, every unofficial observation spreads rapidly across forums, news outlets, and social media. People are asking, when will it be available? How much will it cost? Could this be deployed at scale? And all these questions point to one central reality. This generator is not just a technological innovation, it's a potential paradigm shift. The critical phase now is verification and scaling. Once the device is validated outside controlled lab conditions and demonstrated under diverse real-world environments, the conversation will shift from speculation to adoption. Once the generator proves itself in real-world conditions, the implications expand far beyond technical performance. For households, it could mean freedom from monthly utility bills, a reliable source of electricity regardless of location or grid reliability. For remote or off-grid communities, it could transform daily life, powering schools, clinics, water systems, and communication networks without relying on expensive, polluting fuels. Even entire cities could start to explore decentralized energy models, reducing pressure on national grids and enhancing resilience against outages or disasters. Industries would face a different kind of transformation. Continuous, fuel-free energy could dramatically reduce operating costs, eliminate vulnerabilities tied to fuel supply chains, and allow operations in regions previously considered too remote or unstable. The generator could serve as a strategic advantage for companies and governments alike, providing energy security where none existed before. Yet, with transformative potential comes scrutiny. Regulators, energy analysts, and technology reviewers are watching every detail. Verification becomes the deciding factor between disruptive innovation and unrealized promise. Independent testing, replication across diverse environments, and long-term performance studies will determine whether this generator is truly the future of energy or a compelling prototype. Even in early stages, the attention it draws is staggering. Investment groups, tech innovators, and global media are speculating about licensing, collaborations, and large-scale deployments. And this hype, whether warranted or not, underscores the global hunger for energy solutions that are sustainable, reliable, and independent. But the technology itself is only half the story. The rollout strategy, selective deployment, careful verification, and staged scaling demonstrates the deliberate control required for responsible introduction of revolutionary energy systems. Premature mass adoption could backfire if performance fails outside controlled environments, potentially undermining credibility. What's clear is that the generator represents more than just a device. It symbolizes a shift in how humanity might produce and consume energy, challenging centralized systems, fossil fuels, and the economic structures that depend on them. And now, the world waits, not just for confirmation of its capabilities, but for the moment when this self-powered generator enters broader deployment, potentially reshaping energy access for millions. Because once that moment arrives, the question will no longer be, does it work? And that future, once theoretical, is now within reach. Because every technology that challenges the status quo faces the same tension, potential versus proof. The generator has the potential to redefine energy, but until widespread deployment occurs, it exists in a liminal space, a bridge between possibility and reality. Early adopters, institutions, and pilot programs will determine the pace of adoption. Their experiences will provide the data necessary to convince regulators, investors, and the public. Positive results will fuel confidence, creating a ripple effect across industries and communities. Negative outcomes, or even minor inconsistencies, could slow or stall momentum, underscoring the importance of meticulous testing and staged rollout. Meanwhile, the narrative continues to build. Media coverage, expert commentary, and online discussions amplify curiosity, skepticism, and excitement in equal measure. Every report, verified or speculative, shapes public perception and expectations. The technology itself may remain silent, but the story around it grows louder every day. What makes this generator truly remarkable is not just its technical promise, but the strategic impact of its deployment. Energy independence at scale could empower regions previously marginalized by infrastructure limitations. Industrial sectors could reduce costs dramatically. Governments could reimagine energy policy without being beholden to traditional grids or fossil fuel markets. And yet, even as anticipation rises, the central principle remains unchanged. Verification is paramount. Until independent teams confirm performance under diverse conditions, claims remain potential rather than certainty. Every measurement, every observation, every real-world test is critical to turning speculation into fact. But the trajectory is clear. If the generator performs as claimed, the consequences are profound. A new era of self-sustaining energy, a redefinition of accessibility, and a global shift in how we produce, distribute, and consume power. The world is watching. And when the generator steps beyond controlled tests into broader deployment, the story will no longer be about experiments, rumors, or speculation. And when that revolution begins, it won't announce itself with fanfare or flashy demonstrations. Instead, it will emerge quietly in homes, factories, and communities where energy constraints once dictated daily life. The impact will be measured not in headlines, but in lights staying on, machines running uninterrupted, and costs dropping to near zero. Gradually, the generator will move from experimental prototype to practical necessity, and those who adapted early will gain a tangible advantage. At the same time, the global energy ecosystem will begin to respond. Traditional utilities, fossil fuel suppliers, and infrastructure planners will need to reassess their models, integrating or competing with a technology that doesn't adhere to the same rules. This tension between old systems and disruptive innovation will define the next chapter in energy history. Yet the generator's story is more than just economics and strategy. It's also a testament to innovation and perseverance. Engineers, inventors, and visionaries behind it have pushed boundaries that others deemed impossible, challenging assumptions about what is achievable with energy science. And while the world debates, measures, and plans, the generator continues to do what it was designed to do: produce reliable, self-sustained power. Every uninterrupted hour is both proof and promise, a quiet signal that a new paradigm is on the horizon. The question now isn't whether it works. It's how fast the world can adapt to a future where energy is no longer a constraint, but a constant resource. Because once the MSCD generator moves from selective deployment to widespread accessibility, it won't just provide power. And that redefinition of power carries implications far beyond individual homes or businesses. Entire regions could gain energy independence, freeing themselves from fragile grids and costly fuel imports. Communities previously considered off-grid or energy poor could suddenly access consistent electricity, enabling schools to run reliably, clinics to operate uninterrupted, and local economies to grow without the traditional energy bottlenecks. Industries would see a different kind of transformation. Operations could continue without the fear of supply chain disruptions, fuel shortages, or power outages. Manufacturing, logistics, and even high-tech sectors could leverage this self-sustaining energy to scale faster and reduce operational costs. At the policy level, governments might rethink energy regulations, subsidies, and infrastructure investments. If devices like the MSED generator can deliver continuous, verified power, the traditional centralized grid model could be challenged, potentially decentralizing energy production on a massive scale. Yet the pace of this transformation depends on verification and replication. Controlled tests and pilot programs will determine whether the generator performs consistently across diverse conditions and geographies. Only then will confidence grow, adoption accelerate, and the technology move from alleged breakthrough to global standard. Meanwhile, public perception continues to evolve. Media coverage, online discussions, and social speculation feed excitement, skepticism, and curiosity in equal measure. Each rumor or report adds to a narrative that is larger than the technology itself, about possibility, innovation, and the future of energy. And through all of this, one principle remains clear. The generator doesn't need publicity to prove its value. Its performance, reliability, and potential impact speak louder than any headline. The next stage is inevitable. Controlled deployment will give way to broader availability. Pilot projects will expand into communities and cities. And when that happens, the world will see firsthand what it means to live in a world where energy is self-sustaining, reliable, and accessible to all. And that brings this story to its conclusion. The MSED generator, whether still in controlled testing or on the verge of wider deployment, represents more than just a new piece of technology. It symbolizes a shift, a move toward energy independence, sustainability, and accessibility that could transform homes, industries, and entire nations. Its quiet operation belies the potential disruption it could create: decentralized power, reduced costs, and unprecedented resilience. The world watches, debates, and anticipates, but the device itself continues its work, silently powering the future. When verification, scaling, and adoption are complete, the question will no longer be whether it works. It will be how fast the world can embrace a future where energy is constant, self-sustaining, and no longer a constraint on progress.